started. So welcome to this presentation, Modernizing Your Plant Floor in Under an Hour. We're going to do this a little bit differently than maybe some of the other sessions you've seen the last couple days. We're getting into the home stretch of the event, so you might be a little fatigued, but we're going to do 3 things actually, and we'll have a bonus 4th thing today. So we're going to start off with Craig Resnick, who's with us. We've been working with Craig some time to talk about the Edge server marketplace. We are from Stratus, and that's what we specialize in, is we build mission-critical server infrastructure. Roughly a little more than half of our business is actually deployed at Edge, and our #1 market segment is the industrial automation verticals. So Craig has been a really good partner with us, and he's going to talk through some of his latest research. The other thing is that on Monday we launched a brand new Edge optimized platform, and the first user of that is Facility Connects. I have Tom Schiller here from Facility Connects to talk about how their customer Doosan got their fuel cells hooked up to the cloud with a new Edge solution. And then I will be talking a little bit about the new product line. The bonus 4th item is actually we'll be setting up one of these brand new systems. So the context for our conversation today is our brand new product line, again, that we announced on Monday. This will be available to customers in May, which we call ZTC Edge. And the idea is, how can we provide a zero-touch compute platform for Edge environments, particularly the remote Edge environments? One of the nice features of this is it sets itself up in under an hour, but the real core capability of it is it actually has self-protecting capabilities built into the software layer that virtually eliminate unplanned downtime, and also allow you to have a very rich managed service type of model, which we'll talk about a little bit later on. Again, this is also delivered at a pretty low price point. So this is like I said, kind of a different type of Edge infrastructure that we've really just invented. So while we're talking, since we think we can get this done in under an hour, gentleman from my team over here, Oliver Gruner, is going to get started on setting one up, getting it running, and getting it all synced up so you have a very simple, highly available, resilient mini cluster, if you will, deployed right here while we speak. So on that note, I'm going to turn it over to Craig, and he's going to walk us through some of the latest trends in Edge.
Thanks, Jason.
Yeah.
No pressure, Oliver. Nothing ever will go wrong. It'll be perfect. It'll be perfect. I'm Craig Resnick from ARC. I probably just saw you a few minutes ago over doing some sessions in the next room. Working with Stratus, we actually commissioned a survey regarding the Edge, because more and more of our clients not only are asking us questions, but they're trying to figure out how to reconcile the Edge. What does that really mean for their existing installed base? How does the Edge and the cloud work together or coexist? And so we tried to put together some questions around that. And if people are interested in there's a white paper that's written on this subject, and I'm sure you could talk to your people here at Stratus. I'm sure they could get you, show you how you can get a copy of that paper. If you're ready, you already got it. You're ahead of me. But when we did the survey, we were able to get at least over 300 end user responses. There are no suppliers or systems integrators in this mix. Strongest in North America as far as response, but still a decent balance with 30% from Asia and 20% from Europe. As you can see, it's a little bit of an eye chart, the number of industries that responded, but so we don't have to have every graph with 50 lines, we just consolidated to process industries, discrete industries, and then overall, which you'll see as we go. Sometimes we ask some questions that we kind of know the answers ahead of time. We just don't know, maybe to the extent of what the answer is going to be. But when we asked the question of, the mix of computing power, both at the Edge and in the cloud, is that going to be part of the industrial automation infrastructure? We expected pretty much unanimous agreement, and we got that. What you notice is it's even slightly more unanimous in the discrete industries than it is in the process industries. But overall, it's something that I think we certainly anticipate going forward. And again, not a surprise to the question. And as far as having better systems and connectivity at the edge, enabling real-time decisions, this was actually we also figured this would be very high, but it turned out that it was also a little bit higher than we thought. And the reason for that is because we're finding more and more of the respondents are looking at some of this data not only as the traditional, flow level, temperature, pressure data that may go into a DCS system, or the, photoelectric proximity sensor data that might go into a PLC or a PAC, but they're thinking in terms of this is data that may be used, let's say, on the edge, that may be used for asset performance management, that may go directly to a cloud platform like an Azure or something along those lines. So that's one of the reasons why they really think that data has to be far more real time than maybe they would have thought of that in the past. So then we say, as far as do you see, is cloud going to win? Is edge going to win? Or is it going to be a hybrid type of solution? And this is one that probably was finished a little bit higher in hybrid that we may have thought, thinking probably getting in the mid-50s to a little over 60%, with discrete being the strongest as far as the hybrid between the two. But interestingly enough, edge, no pun intended, edged out cloud when somebody decided to pick one or the other. And what we typically find is when we talk to a lot of the respondents, which is no different than typical discussions we have with clients, many times people are looking at the cloud as something that's great for historians and say MES type production management data on up, but there's always some that are a little cloud resistant when anything comes to real time, and that's why they will always vote for the edge and be able to do that analytics at the site of the measurement, or at least as a hybrid application with the cloud, again, to store data that's not going to be required for real time, such as, say, a historian. Then we ask the question as far as real-time analytics, as far as, where is it going to be deployed? And this one came out, a little more balanced than we thought. We had thought that maybe the cloud or the data center might be about a 25% each, but it turned out that both edge and plant floor were seemed to be the winners. Again, you can really see it the edge really coming out strong for the discrete respondents. But here's a case where there's still that feeling that, again, if we're going to be gathering data, we feel more comfortable, leveraging a lot of the analytics technology that's available and the embedded technology that's available by doing the calculation right at the point of measurement. So some of them when they would pick plant floor, they want to keep that calculation done where the input is being derived. Then we ask them as far as top 3 needs, as far as driving your plans to deploy systems and connectivity at the edge. And these would be ones that we certainly would expect would be the leaders as far as for analyzing and controlling devices, thinking that they still have the need to make the measurement, again, either for control or for managing assets and doing anything that they can to eliminate unplanned or unscheduled downtime. And by improving process speed or latency, the follow-up response was obviously people are still looking at their KPIs, and if there's a way of adding some information from the edge that's going to help improve KPIs or an OEE score, for example, then that would be something that is very interesting. And then the third was trying to find out how to reduce data security risks. That was a case where some of the people tended to look more at edge and plant floor more so than cloud when we asked from a concern on that level, even though many times when we talk to them as far as the fact that much of the cybersecurity expertise is really amongst the cloud providers. So, but there's still that feeling that sometimes putting things in the cloud from the people more so that come from the OT side of the world, don't have that same level of feeling comfortable as people, say, that coming from the IT side of the world. Then we ask kind of where is your organization currently as far as learning about the edge. And what we found is, as you can see, there was the biggest respondents were the education mode, so we're still in learning mode, and then also conducting a pilot. So it seems to be, you don't have a lot of people who've kind of already getting edge results. I mean, if you look at the stats, average of 12% with discrete a little higher than process at 16%. But for the most part, it really tells us that this is still an industry where people are testing, a lot of beta testing, and still trying to figure out what direction they want to go. And I'd say one of the reasons why we broke attendance records at this forum is because people are really in education mode and trying to learn more about subjects such as the edge and analytics and how that's going to affect their plant in the future. And then as far as who's going to have the responsibility, and this is really, again, this finished from this is part of a lot of what we do for IT/OT Convergence. And it was interesting how strong that response was. And that really comes in line with what we see as we're working with different organizations as far as at least the initiatives that they have to kind of continuing to accelerate IT/OT convergence. I'd say there's very few organizations that haven't at least have begun the process of converging the two groups. But this just feels as though that's where the responsibility for the edge is going to end up. So, from a quick recommendations, I think that I want to say just about everybody's at least thinking about the edge. I really haven't seen anybody that's really told us that's not come up in any of their planning. As far as IT/OT convergence is concerned, it's also a matter of not only the technical convergence, but the human element of convergence. In our IT/OT convergence session that we actually held just before lunch, we actually had one of our speakers really discuss the whole human element of IT/OT convergence and having these people work together and how to kind of break down the firewalls culturally between the people from the different groups. So, and I think it's also going to change as far as how people look at how they control things and monitor things from local and remote. And I think what this does for a company like Stratus is, at one time, by having systems that prevent any unscheduled downtime, the idea was to always make sure that you always had power and redundancy on anything from the control system. But I think what this is saying, based on these results, is that some of those edge connections are going to have just as detrimental effect if that connection is lost or on creating an unscheduled downtime. So you really need to make sure that all those edge connections are going to have 100% continuous availability. So with that, there's far more detail in your white paper from this survey, but I'll be happy to take any questions after that.
Thank you.
All right, good afternoon. First off, for those who have either sent flowers or not sent flowers, happy Valentine's to everybody and their spouses. I know some of the ladies here, giving up your Valentine's Day. So first off, and I did send it to my daughters and my wife, so we're good. So first off, my name is Tom Schiller. I'm the CEO, founder of Facility Connects, and I'm going to tell you a little story about one of our customers, an OEM called Doosan Fuel Cells. They have about 25% of the worldwide fuel cell market, and they make a 400 kW fuel cell. I'm going to talk a little bit about that. So, oops, wrong direction. There we go. So first off, a little bit about Facility Connects, because I'm sure nobody in this room probably knows, outside of maybe a few people who know me pretty well, who Facility Connects is. We started developing this solution, and again, we're not a platform, we're a solution for smart intelligent buildings, smart intelligent manufacturing facilities, smart intelligent hospitals and universities. So those are our key markets that we focus on with this. It's built on Amazon. It's a continuous monitoring solution, so remote monitoring, fault detection, diagnostics. Those are the key things that we do. It comes with a mobility application as well. It provides you with notifications, alarms, all sorts of actions that are going to drive you and your maintenance operations to fix things that we're identifying as problems with the fault detection on the equipment. We like to say we're the voice of your equipment because we really bring out what's going on with the piece of equipment. Is there something wrong with it? And we go deep into the equipment. We don't just look at it from a holistic, either a building or the holistic equipment. We drill right down into the details of it. So sometimes you require extra sensors for that. That's the whole IoT part of it. And we bring all that information up. So one of the key things that we really needed to do was figure out is how do we make sure when we're putting all these fuel cells or other customers, thousands of locations all over the world, how do you make sure, one, it's secure, two, it's up and running all the time, and your data is always coming back. And I've been working with Stratus for a while, and their fault-tolerant edge device was something that they came up with that would apply to an edge-based solution. And so I'm going to talk a little bit more about that in a minute. But one of the things we do at Facility Connects that really sets us off a little bit differently is we really help identify all the way down to the actual cost of the fault, of what's going on, to show you what's the most important thing you should be doing to fix things around that. So I'll give you a couple examples when we get to further in this. And every single month, my team sits on a phone with the customer reviewing those details of what's going wrong, and so that you don't have false positives of what's happening, we verify, we modify, we tweak, we use machine learning to keep learning what's going on with the equipment. So all this data coming from the field is all flowing up into Amazon, which is where we keep our platform. So let's talk more about how we do this a little bit. So you've heard a lot this week about things like fault detection, analytics, and all that. The word analytics to me is still kind of a broad term that you can just have rules. Well, what's the difference between a PLC doing alarms and an analytic that kind of triggers on a level? You can do it similarly those ways. I look at real analytics where we're looking upstream, downstream of the equipment and trying to see what's really going wrong with the piece of equipment. Something that it would take a real intelligent engineer going through the data, looking over historical stuff to really kind of find out what the root cause is. So, for example, in a hotel building like this where you've got an air handler, simultaneous heating and cooling is a big problem. Leaky steam valves are a big problem. And for those people who don't understand that, which, until about 8 years ago, I really didn't understand it, but we dive into these things and we can tell really quickly what's going wrong with the equipment. We have one customer at Greenville Health down in South Carolina. We had our first experience call, and the engineer and the analytics identified 50 leaky steam valves. The ROI on that system was 11 hours, right? So it was crazy. The guy wrote it up, sent it to his boss, and said, "We've already paid for this for the next couple of years with this finding." So that doesn't happen all the time, right? Normally it's a 6 to 8 month kind of return, but in some cases we find things so quickly with the analytics that it really pays for itself well. So one of the other things, we just did a webinar with one of my large customers a couple of weeks ago, and he educated me on the fact that it's not just about the energy savings that we're doing it. You're actually making my assets last longer. You're optimizing my assets, you're taking a look at my motors, you're taking a look at my equipment, and you're making them operate better, therefore they're not operating as much, therefore they're going longer. You're telling me when I'm supposed to do maintenance on them, so therefore it's extending the life of that asset. He goes, "You don't know how valuable that is to us." So some of those kind of experiences we've had with our customers are really kind of nice. So the key thing is we need the data, right? Brings us right back to Stratus, which in this picture you'll see here, just so I have is the laser button here? Okay, so what you see here is at the fuel cells, these are all edge devices. So any of the equipment or buildings that we monitor, those are out here in the edge. And we've got thousands of those that we're all connected to. And for this customer, we're getting about 750 tags a second coming through the system and then being relayed up into the cloud. And then we're doing analyzation on how well that fuel cell is performing. So we've installed now this Stratus box at the edge because these things go all over the world. So in South Korea, they've got over 100 of them out there, and some of these in locations where communication is not real good. So we got to make sure that this works well. So we have a real secure connection all the way back up through, only outbound traffic going up into our cloud. We do not send data back to them. We could, but we don't want to do that. Each customer is a little different. So secure connection out here. We're actually tying this up into a GE Predix machine. So a Predix machine is running here on the edge. And my development team is going to be developing, and we've already started the development process, is running edge analytics. All of our analytics currently are running here, but the desire for customers, in a lot of cases, just what Craig was talking about with the surveys, a lot of them want to be able to run it here at the edge. And then we're going to get to closed loop control where you can not only run them at the edge, but send the control back. And then the resulting information, send it up the cloud for further analytics. So, you know, we've got these out there in the field running. There's probably 3 or 4 VM images running on a box out here because we have some other applications the customer wanted to put all on one box. And we store it up here. They've been running data across almost 300 fuel cells, and we've got about 7 terabytes of data that we kind of go through to analyze for their fuel cells, so quite a bit of data. This is a live picture of where we first set it up, and as you can see, Oliver's almost there. I think yours looks a little bit better than ours did after we took a picture there. We kind of were testing it out there in their fuel cell. So, and this is what it looks like. You can see over here on this is the Stratus boxes right at the edge there. And the beauty of these, if you haven't gone up and seen them, they're really kind of temperature, all-inclusive, what you'd expect to see in an industrial enclosure. They really kind of, it's not like you would see a rack mount, like the FT server that you would see from Stratus. This thing's going to go into places that are harsh. I'm going to put them in places that the temperature is going to go all over the place, so that you're going to have to be from 0 to 50 degrees and be able to kind of operate these units. A lot of my customers are having them in harsh locations. So this is the kind of device that Stratus has come up with, and I think it's going to be a great solution for them. So a little blurry here, and some of it's on purpose. So this is a list of all of their customers of Doosan. So I had to kind of blur that out a little bit. But what you'll notice on this screen, this is a dashboard of ours. My favorite part of this is what the CEO and the CFO does at Doosan, is they look here to see how much money it's costing them right now to run these fuel cells, because they moved their business from selling a 400 kW fuel cell to, I'm going to sell you power. So therefore, there's a contract that they have to guarantee a certain output. So we do all the calculations and the analytic predictions of where that's going to go, so they can see exactly what it's going to possibly cost them or make up they're doing. So you can see the ones that are off up here. You can see how much power they're producing. You're seeing all the capacity that they have. And then here you can see in the bubble chart real quickly which ones are the worst performing. So if you click on that one, you'll see all the details of what's going on inside the fuel cell. You can see all the ones that are really operating well. And this is the lifespan of the time of their contract. So he knows that one is going to cost him. This is another view of another dashboard we have for them. Again, this tells them the status of whether the fuel cell is up and running or not, and the trend of what it's doing, a real kind of small view, but again, you can click on it and blow it up into a big one that looks like this down here. And then a message board that allows them to communicate back and forth with their customers around what is it that's going on right now. So maybe I have to take it down, I need some water, or something needs to happen to that fuel cell. And they keep a log of this all the way through their communications with the customer from startup all the way through as long as they need it. So with that, I'll turn it back over to Jason, and I'll take questions at the end if you have any.
So thanks, Tom. Thanks, Craig. So I think, Craig's done a nice job of establishing why the edge is important, and Tom has given us this really excellent use case of kind of a new edge environment. We started working on this thought about 2 years ago. And as we started to recognize that, at 2 years ago, if you think back to maybe shows here or other shows you might have been to, it was cloud, 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 cloud. And we were sitting there scratching our heads going, well, wait a second, if you think about our business, it's very heavily SCADA driven in terms of our edge use cases, and how many tags are they going to be able to run, latency, networking, all that stuff. And we were like, well, that doesn't make sense. And then we started to realize that there was even more compute power going to places where there was less people and less networking. So we always had talked about low IT resources as a reason to choose Stratus products. What we challenged ourselves with was how can we build a platform that has no resources, right? So really what we announced on Monday was the first generation of what we call ZTC, which those initials stand for Zero Touch Computing. The idea is how can we completely eliminate the need to touch these things or manage these things at the edge at all? So before I jump in, how's it going, Oliver? You doing good?
I'm doing very well. Just waiting for a little bit of feedback. I typed in all the parameters I needed for my network, and in just a few more minutes we'll be all set.
Great. So he unboxed, so he had a beta unit, basically got shipped, showed up, shipped, opened it up, ready to go, because the whole thing is preloaded and ready. There's no idea of, well, geez, now I have to install this, or I have to connect an external drive, or I have to install VMware. This thing will be, by the time I'm done, my lips to God's ears. Oh, there you go. So you're done. You could load a SCADA VM on there right now. There you go. So and it's highly available. So if one goes down, the other picks up, right? Seamlessly.
I can do it. You can do it.
Well, I'll be happy. So let's talk about this for a second. In the slide I showed at the beginning, right? I said under an hour. Of course, that was the first beta test. That was Tom's team was working with us a couple months ago, and they got it done in about 45 minutes, and we set a design goal of under an hour. My product management team, being the types of guys they are, who are loved by our engineering team, they said make it 30 minutes, and Oliver, you're at 27-ish minutes right now. Great job, thank you. So, and we're up and running, so start adding apps, right? And again, it's a redundant system, so we set up two systems. They're syncing up with each other, and off you go to the races. You can start putting, you could use a USB key, not really secure, put a VM on there, and off you go. The whole point of doing this is, again, to make this thing a very efficient machine. So this machine comes preloaded with virtualization out of the gates. You don't have to install it. It's ready to go. It's based on KVM, the Linux virtualization. Don't be afraid of Linux, especially how we've tailored it, because we've built a lot of extra capability, and really in terms of the user experience, I invite you to go up after we wrap up here. You can see that it's a lot like configuring a router at home. I mean, we made this for OT people. I think that's the most important message for you, is that we didn't approach this like other infrastructure companies who build tools for IT people. We knew that this was going to be deployed in places where IT people might not venture, so we built it around them. And that really brings us to reducing the IT burden. There is a real emphasis for us to make sure that the system protects itself. So if you think about a lot of common monitoring solutions out there, they're kind of calling and polling your end system. They're going, hey, how's it going, right? Well, if you have low connectivity, or if you have a need for an immediate failover, or a problem starts to manifest itself very quickly, you actually want the system to take care of itself and call you, right? And that really is the foundation of our service business anyways for the last 30 plus years at Stratus. But we decided to take that to an edge form factor and build that telemetry into the system. So we took a standard kind of variant of Linux. We built the OT management stack on top of it, but underneath the covers, we also built a lot of advanced telemetry for both the hardware and the software stack, so it can protect itself. Those two factors alone mean that IT doesn't have to put as much time, effort, money, confusion, whatever, into the scenario. So that's a good thing. We are a mission-critical infrastructure company. We protect a very high proportion of the world's financial transactions in terms of credit card transactions. Something like 70% of credit card transactions in Japan run across Stratus. We do landline phone networks, all kinds of stuff. So we're all about preventing unplanned downtime. This system leverages very similar technology to our very high-end systems. And like I said, what happens is if the system begins to notice that it's having a problem, it will fail over, right? So it will fail over before there's a breakdown, right? That's the whole idea. So that way nobody's interrupted, you're still collecting data, those types of things. And then lastly, as Tom mentioned, we built it so it could be deployed anywhere. So this is a industrial box. It's an off-the-shelf system. There is no special proprietary hardware here whatsoever. We sourced it from Taiwan, just like a lot of other people. But so all the secret sauce for us is in the software and the service model. So where is this being deployed and used? We are in beta right now. This product will be available in May. We will start taking pre-orders, and our partners will start offering quotations for it in about 2 weeks. The classic use case for this product, and the one we kind of built it around, was the idea of the virtualized ICS. So a lot of our partners in the GE world or in the Rockwell world, we work through that, those ecosystems pretty extensively. They're essentially walking into sites that have multiple industrial computers or multiple servers, and they're consolidating. This system, what we tested out in beta 1, was a combination of multiple types of SCADA systems. So we've done Wonderware System 17, we've got Factory Talk, we've done iFix, we've done a bunch of them, right? Historian complementing that, and then generally some sort of rich client. ACP Thin Manager is pretty common. Our design goal for this is about 10,000 tags. So this is, if you want to do just Historian, it'll do about 10,000 SCADA. So the idea was a 10,000 tag environment for this system and running across 3 virtual machines out of the gates. We're finding that our business for years has really been at the plant floor level, but as Tom has pointed out, we're starting to work on remote sites and even machine building specific sites with this solution because it doesn't require a rack. It can be literally screwed into a wall. It also comes with all the brackets to do a DIN rail mount or something like that if you'd like as well. So it's the idea here is really to take what your common off-the-shelf server does and deploy it in an industrial way, and again, give the OT person the tools that they need to manage it or services that they need to help them manage it better. So that's kind of the idea. So let's talk about how it fits, right? Where it fits, because it's a little bit different. We want to talk. We really, if you think about kind of our thought process around this, when we started sitting down with partners like Facility Connects and others, we basically came to the conclusion that edge infrastructure wasn't really built for the edge. I mean, industrial computers are great, servers are great, but what's that kind of in between? So we looked at the 2 most common deployment scenarios. There's kind of like the idea of buying a standalone industrial computer or just a small server, and then you have a spare. And that spare is probably sitting maybe on the floor, sitting in a closet somewhere in case something bad happens, right? They generally can be deployed if you're putting it together and building your image on it and everything like that, can get deployed in a couple hours. And if there's a failover, hopefully you have somebody there who's quick enough to kind of run into the back room, get the server, remount it, swap out the cables and all that other fun stuff. Then you do a restoration from backup because you are backing all these up, right, to some service, I assume. Oh, well, if you're not, you should be. And that is the kind of restoration process. And then, you got to back it up. And, again, these have some availability capability to it, but you are losing data and you're probably losing hours of data in the event of failure. Ours is a little different in the sense that Oliver just showed you be up and running in under 30. And if there is a failure, generally for us, it's less than 5 minutes. Sometimes the failure is prevented altogether. Usually a catastrophic event would require some sort of different migration. Could take a few minutes. But and again, this is $15,000 all in. Software, hardware, out of the box, you just add your apps. Where we have been operating for years now is at the end, the clustered system. We have Tom made a brief mention of a product called FT Server. It's a great product, and it competes with clusters. The truth is those are fairly complex to set up. You generally need some sort of external storage, 2 systems just like ours, and they generally need help from IT. Sometimes the user interfaces aren't easy enough for people to use, or you're running complex scripts against it. So again, these are fairly expensive. Generally, our benchmarking shows clustered systems somewhere in the neighborhood of $30,000 all in to manage on a yearly basis, TCO cost. And then your standalone plus spare somewhere in the neighborhood, depending on how you're doing backups and so forth, could be somewhere in the 10,000 range. So this is kind of the, sweet spot, right? It's just right. So like I mentioned, this is a product line for us. This is a new type of infrastructure. Kind of when we think about it, I try to think of things less like servers, and I think more of like an Xbox. Right? A system that will have things running on it locally, but it'll also have a rich connection to the cloud for enhancements or other analytics applications or things like that. So it is a hybrid device. And what we see is kind of this evolution of applications happening at the edge. I mean, a lot of people have been talking about this week, so there's not like anything crazy, but in our effort to simplify these applications and simplify their implementation, a lot of it comes back to standards or best practices. So what we decided to do in Generation 1, which is coming in May, is really focus on the ICS. We have a lot of experience there, fairly mature market, fairly standard. We have all the partnerships in place. So we really built this around the ICS use case. It is a redundant monitored system, and in this particular generation, we're monitoring the hardware and the operating stack itself, the virtualization engine and all that. And again, rugged and simplified. Every day we talk about different analytics cases, and Tom is spot on. I've probably talked to 20 or 30 analytics companies in the last couple months. They're all a little different. They all have a little bit of a different architecture. We are kind of trying to find what that next sweet spot is in terms of, is it an industrial device? Could we do an industrial that's bigger? Or what's the right price points for that? What's the right storage technologies and so forth? So Generation 2, we're really looking at analytics as to find kind of, again, an Xbox-ish experience for analytics at the infrastructure layer. But we're also going to be adding a couple new features that'll be significant. The first is we are going to build a very hardened system in Gen 2. So it'll be very protected, tamper-proof designs. Some of the stuff that NIST is talking about is very interesting to us in terms of whitelisting built into the box and outside of the software, and build in some really hardcore security features. But in addition to that, we'll take our monitoring capabilities to a new level in the sense that we will be able to monitor for security events. If you're deployed out in one of these fuel cells and somebody breaks into it and gains physical access and plugs a USB stick into it, that is a security event. So we should be monitoring the system to let you know that. If somebody all of a sudden maybe accidentally installs the wrong kind of application, that should kick off a service ticket. So instead of it just being a kind of service model where we're watching our own stuff, we're going to begin to move into full stack monitoring where we'll take care of the system in a much more robust way. And then lastly, zero-touch management is where we get to the point where there's two aspects to this. The customer must be ready and we have to build the offerings, but ultimately the point is that at some point we expect to see customers more willing for us to help push things to the system, maintain it. One way to keep the system secure is to patch it, right? So patching services, different types of capabilities will be coming on, and that's when we really believe that in the next couple of years we'll arrive at what we'll call truly a zero-touch platform. That will influence things like cloud. That is where you start to see scale-out architectures where, you know, a smart city might have a bunch of these nodes pushed out all over the place, and they're connected via a telecom network using technologies like NFV type of technologies, or using or renting space in a carrier office remote data center, which is what CORD stands for. So we're starting to kind of think ahead to that stuff, but which is really kind of the more future-y stuff. But for today, in terms of modernizing your plant or taking your plant technology to places where it's never been before, we think we have a great solution for you. On that note, we're a little ahead, which is great. We'd love to open it up for questions, or if anybody wants to go up and torture Oliver, we'd appreciate that as well. Questions? Yeah.
Doesn't the degradation of that equipment happen way before the 40 minutes or 30 minutes?
So when we talk about the actual predictiveness inside our system, we're talking about our system itself. So when we get into, so what we're doing is we partner with companies like Facility Connects to do that type of thing. So
Is that question more for me?
Yeah.
On that one?
Just on the solution,
Yeah.
I understand the context of it, but the ability to identify the failure before there's actually any impact to the equipment, that's what I was asking.
Yeah, it all depends upon the pump curves and what the data is you're getting from the equipment, right? So, I mean, when we look at an easy one, or one to look at is like motor failures, right? That you're going to look at, you know, if you're trying to drive water or whatever the liquid you're trying to push through, how well is it performing compared to what it was? Do you have vibration sensors on there? Do you have the current that's coming out from the motor? All the different elements around it are going to allow you to build a model associated with that to be able to predict it. And sometimes you can predict it as much as a couple of weeks ahead of time, depending upon what the system's doing, that it is degrading. Because you know its performance, right? What it should be.
Good question. Go ahead. Yeah, please.
So I'm Nate with GE. So how do you think about handling incomplete data or bad data? And maybe it gets into some of the modeling aspects of it, but are there any strategies you look at? Because one of the things that we struggle with is thinking about source systems,
Yeah.
trying to eliminate the prerequisites of all this setup. You need to make sure that everything's fully complete and cleansed and tested before you can actually get value out of it. How do you think about filling some of those gaps?
Is that back at me?
Yeah.
If there are
So-
any
so-
ingestion strategies around incomplete data or source systems.
So I think in terms of ingestion strategies, we tend to, I would say, where we come into the picture more is around corruption. So not necessarily on the ingestion side. So we're looking at the data. One thing, like I mentioned with full stack, is our idea is to go beyond and go into the virtual machine. It's a virtualized system. All the apps must run in a VM. And so we're working on that type of technology to prevent corruption, because if you start to sense that there's a corruption on one side of the redundant, you want to fail over and kind of isolate that, right? So that's something we have some capability to prevent against now, but we're going to go much deeper on it in the future. And really that's just through monitoring the storage and data checksums. I mean, it's pretty simplistic right now. I'd say when you start to get into the more ingestion side, in the advanced use case, we tend to turn it over to the partner and work on the application
Yeah,
side.
so I mean, we use typical algorithms to look at the data. So like even like we know when a sensor is out of calibration, right? It's got certain things. So on every signal we're bringing in, if it's a critical signal, we'll look at it for quality. And if it's within a range of certain amount, or if it's just off the chart, you kind of wait for a couple of samples in order for it to be really read that way. If not, we actually ignore it, right? You got to look at the rules up and down from the data to see if it's valid. And then that's where the analyst also comes into play to say, is this a false positive or something, and then what could be the problem? So as much as you want to count on that data, you still have to have some verification on it.
That's fair. Any other questions? Okay, going once. Well, I want to thank you all. Like I said, if you want to come check out the UI or ask Oliver questions about the product, please come on up. We do have some time before the next group comes in, and enjoy the rest of the show. Thanks.